Hello everyone. In this video, we are going to discuss about the blocks in the modern periodic table. Specifically, we will be discussing about the P block elements in this video. See, we have already discussed about the S block elements and we will be discussing about the F block, D block, etc. and everything will be available in the playlist. So, you see, the elements belonging to group 13 to 18 in the periodic table are called P block elements. So this is group 13 elements, then group 14, 15, 16, 17 and 18. So you see these elements are actually belonging to the group, belonging to the P block elements. Okay, so you see the elements belonging to group 13 to group 18, they are actually called as P block elements. And you see at the end of each period of the P block element, it is a noble gas with a closed valence shell, that is fully occupied shell. That is, here you see when you consider this period of the P block elements, at the end of this period you have neon, which is a noble gas. When you consider this period of the P block elements, you see at the end of this period you have argon, which is also a noble gas. So at the end of each period of the P block elements is a noble gas with a closed valence shell, that is fully occupied shell. Now, when we consider the outermost electronic configuration of P block elements, it varies from Ns2Np1 to Ns2Np6. That is, when you consider the outermost electronic configuration of each element in the P block, you can see the outermost electronic configuration is just like that, like 2s2 2p1. Okay, then 2s2 2p2, 2s2 2p6, then 2s2 2p6, like that. 3s2 3p1. 3s2, 3p2, just like that. And we have seen that at the end of each period of the P block elements, it is a noble gas with a closed valence shell, that is fully occupied shell, and it will have that is the noble gas will have this outermost electronic configuration, that is Ns2 Np6. See, this N can have values 1, 2, 3, 4, 5, etc. See, the noble gases, they belong to the P block category. See, all the orbitals of the, all the orbitals in the valence shell of the noble gases are completely filled by electrons, and it is very difficult to alter this stable arrangement by the addition or removal of electrons. So, noble gases exhibit very low chemical reactivity. You see, when we consider the group 17 elements, they are actually called as halogens. They also belong to this P block category. And when we consider the group 16 elements, they are also called as chalcogens. They also belong to this P block category. So you see the elements of these two halogens and chalcogens are generally non-metals. That is, the elements of these two groups have high electron gain enthalpies and readily add 1 or 2 electrons respectively to attain the stable noble gas configuration. Because stable noble gas configuration provides stability and minimal reactivity. For example, if you consider the elements of group 17, which is also called as halogens, they try to gain 1 electron to form a stable noble gas configuration. Because stable noble gas configuration provides stability and minimal reactivity. So if you consider one group 17 element, which is fluorine, its atomic number is 9. So electronic configuration is 1s2, 2s2, 2p5. So here you see 1s orbital is completely filled, 2s orbital is completely filled, because the maximum number of electrons possible in s orbital is 2. When you consider this 2p orbital, the maximum number of electrons possible in p orbital is 6, but here 1 electron is less. So what this fluorine will try is, actually the fluorine will try to gain 1 electron. So it gains 1 electron, it tries to gain 1 electron, and it becomes a fluorine ion, that is F minus ion. So that now this fluorine has 1 extra electron, so that its electronic configuration becomes 1s2, 2s2. Earlier it was 2p5. When it gained 1 electron, now it has 6 electrons in the 2p shell. See, this is actually the electronic configuration of neon. So it attains an electronic configuration just like that of neon. That is, it attains the stable noble gas configuration. So the elements of this group 17 group try to gain one electron so that it attains a stable noble gas configuration. Similarly, when you consider the chalcogens group, which is group 16 elements, you see the elements of group 16 will try to gain 2 electrons to form a stable noble gas configuration. That is, if you consider one group 16 element which is oxygen, its atomic number is 8. So electronic configuration is 1s2, 2s2, 2p4. So you see 1s orbital is completely filled, 2s orbital is completely filled with electrons. Now when you consider 2p orbital, the maximum number of electrons possible in p orbital is 6, but here only 4 electrons are there. So 2 electron less. So what will this oxygen try is, it tries to gain 2 electrons. It gains 2 electrons so that it becomes O2 minus ion, oxygen ion. And its electronic configuration now it becomes 1s2, 2s2. Earlier it was 2p4. Now it gained 2 electrons. So now its configuration will be like 2p6, which is actually the electronic configuration of neon. That is, by gaining 2 electrons, oxygen attains a stable noble gas configuration, which gives the oxygen 2 minus ions, O2 minus ion, stability and minimal reactivity. And you see, the non-metallic character increases as we move from left to right across a period. Because from left to right, the electronegativity increases, atoms become more likely to gain electrons and exhibiting non-metallic behavior. That is, in a group, in the periodic table, as we move from left to right, the non-metallic character increases. And you see, the metallic character increases as we go down the group. Because as we go down the group, the electronegativity decreases and atomic size increases, so that atoms become larger. That makes it easier for them to lose electrons and exhibit metallic character. So the metallic character or metallic behavior increases as we go down the group. So in this video, we have discussed about the p block elements. I hope it is clear to you. Thank you.